Welcome again to our chemistry class. I hope you're all doing well. Today we will discuss electronegativity difference and bond polarity. Objectives. At the end of this lesson, you should be able to identify polar and non-polar bonds and describe the relative degree of bond polarity. What is electronegativity? Electronegativity is a measure of the tendency of an atom to attract the bonding pair towards itself in a covalent compound. This electronegativity is inversely proportional to the atomic size. This means that as the atomic size increases, the electronegativity decreases, and as atomic size decreases, electronegativity increases. Atomic size increases and electronegativity decreases. How is bond polarity affected by electronegativity? In molecules or covalent compounds, we distinguish two types. The first one is homonuclear molecule and the second is heteronuclear molecules. In homonuclear molecules, we have atoms which have same electronegativity values. We have same atoms, and the same atoms have exactly the same nuclei. So the attraction ability of the two nuclei or both nuclei is exactly the same. And as a result, we have the bonding pair which is equally shared. No atom can attract the bonding pair more than the other. And in that case, we have a pure covalent bond where the bonding pair is 100% equally shared. In heteronuclear molecules, we have atoms which have different electronegativity values, and this is due to the fact that they have different nuclei. And in this case, the bonding pair will not be equally shared. Instead, it will be unequally shared because one of the atoms is more electronegative with a greater tendency of attracting the bonding pair, and the other one is less electronegative with a smaller tendency of attracting the bond pair. And in that case, the bonding pair will be closer to one of the nuclei, making the bond resulting in a polar covalent bond. In a polar covalent bond, the bonding pair is closer to the nucleus of one atom than the other. And the greater the electronegativity difference, the higher the polarity of the bond. As the electronegativity difference increases, the bond becomes more polar and eventually it ends up becoming ionic. As the electronegativity difference increases, the covalent character of the bond reduces and the ionic character of the bond increases. Here we have a table showing the electronegativity difference, the type of bonding, and the charge distributions. We have the bonding type here, electronegativity difference, and the distribution of charges here. For non-polar bonds, the electronegativity difference is between 0 and 0.4, and for polar bonds, the electronegativity difference is between 0.5 and 1.8, while for ionic bonds, the electronegativity difference is from 1.9 and above. Here we can see that the charges are evenly distributed. We have same colors, while here the charges are not evenly distributed. Chlorine has the bonding pair closer to its nuclei, while hydrogen has the bonding pair far from its nuclei. And with lithium chloride here, the bonding pair is also closer to chlorine, which is more electronegative, and far from the nucleus of lithium, which is less electronegative. As the more electronegative atom attracts the bonding pair towards itself, it becomes partially negatively charged, and the less electronegative becomes partially positively charged, and we represent the partial charges by delta. We use delta positive for a partial positive charge and delta negative for a partial negative charge. And on a molecule, we represent it as shown in the example below. We have an example of hydrogen fluoride, where hydrogen is the less electronegative and fluorine is the more electronegative. Hydrogen, which is less electronegative, will take a partial positive charge because it looks like it has lost the electron, or it is about to lose the electron, and this fluorine is about to gain the electron. But because both atoms are nonmetals, no one can lose, no one can gain from the other. So they carry partial charges. The one which is more electronegative seems to have taken the electron, and the other one, which is less electronegative, seems to have lost the electron. And then they become partially positively charged and partially negatively charged, and we represent this by this arrow showing the movement of the charges. The charges are moving from hydrogen to fluorine, which is more electronegative. So the arrow shows the pull of electrons of hydrogen towards the more electronegative atom, which is fluorine atom. Exercise now. Based on electronegativity values, which bond is most polar? We choose the most polar bond. Which fluoride is the most ionic? And which compound has the least covalent character? Use a diagram to show poles and dipole moments in a water molecule. The dipole moments are shown by the arrows moving from the less electronegative or the positive pole to the negative pole. Hope to see you soon in another lesson. Bye bye.